Yeah, so I'm working for General Motors. I've been working there for the last 6.5 years, ever since General Motors actually opened up a research center here in Israel. General Motors came to Israel because of the startup nation that we have here. There are some areas where it's really hard to attract people to work in Michigan. Whoever have been there, especially in the winter, knows that it's really, really tough country to be there in winter. Although I like it to travel there. But so for some areas, in particular areas such as computer vision, cybersecurity, wireless technologies, and also human-machine interface, General Motors has engineering teams and research teams here in Israel, and I'm part of it, of the human-machine interface group. We have some people working in the speech area. Today I'm presenting one of the projects that we have started here and that are going into production in the next model years of the Cadillacs and Chevrolets in this world. Initially, of course, in America, but as it's algorithmic technology with only some language development, we are going to carry this over to Germany, China, and hopefully other countries as well. So this project is in particular about user adaptation, but let me first take you a little bit into the world of automotive, what we are doing there, why, how. What you see here is center stack screen of the Cadillac Q system from the last model years. It's a touch screen, but you can enable certain applications there as well by speech. For instance, with the push-to-talk button on the steering wheel. So you just push it, and then you can tell the system your request. We are enabling infotainment by speech for some common areas, some very frequent tasks that people like to do in cars, such as phone calls, enabling the radio, their personal music selection, and of course for information purposes, such as enabling a navigation system to get route guidance. We are currently in the process of enabling as well SMS and email dictation or reading back, and also music streaming or radio streaming apps where people could just say, listen to Pandora and then say their favorite channel. So that's in terms of the domains that are interesting in an automotive environment, and it's probably not the end of the list. In particular, if we think of more automated driving, cars that drive themselves gradually. Google is a very good example for that, actually. But General Motors is doing research in that area as well and gradually coming up with features for that. So drivers in particular have more free time to do more. Now, if we talk about speech technologies themselves, then I think Siri or Google are very good examples for, in particular in the last years, bringing a lot of natural language to the table. People not having to say their request in a certain pattern, but using their natural way of requesting things from the system. They could rather flexibly distribute information. Now, the other bullets here are actually rather dedicated now to the automotive environment, not only, but in particular to what I'm talking about. In particular, Siri, Google, and all those personal assistant type of speech systems for mobile phones, they do not really have implemented a lot of dialogue strategies. They have this one-shot approach where you say in one utterance whatever you want, and then they come up with a web search site, and if they really need to, they have some confirmation or disambiguation sequences, but that's as far as it goes. Now, while driving in a car and having to concentrate, first of all and foremost, on the primary task of driving, we have to have more dialogue strategies, in particular for conversational repair and error strategies. Therefore, we are applying a lot of mixed initiative dialogue strategies. In the car itself, we have other modalities available. So our speech system is multimodal. We combine it with currently with the touch screen, with buttons, with haptics. And in the future, we could think about other modalities as well. And I'll show you an example. And now coming to adaptation, we are trying to apply personalization and context to enhance performance and also to enhance usability. So this is what I'm going to talk about today, in particular about the last bullets. Let me show you a few examples. In GM, we would never, ever bring a feature to the car that we have not researched that that's what the user wants or needs. So that's what we do. And we first and foremost start every research with user studies to see what users really want. So we have a lot of user studies. They're all on the road driving. We try to bring to the car prototypes or wizard systems that have capabilities beyond what is in the car right now, so we can study natural behavior and needs. Let me show you just a few videos, and this one is one that didn't work. So I need to enable it, and it's closed. Let me find it. I'm finding it.
Say a phone command.
Call Dave Smith.
Call Dave Smith, correct? Dave Smith, say mobile or home.
Welcome to Verizon Wireless.
So that's
Say a phone command.
That's an example for multimodal interaction that I brought. And it's actually really not a very up-to-date system. It's from 2013. You can see it. The TTS also is not really up-to-date. But what it showed was that for particular reasons, such as a shortcut, a perceived efficient shortcut, for instance, we have screens where we can combine speech with touch, and so finish the interaction by touch, to particular dialogue steps by touch. And we also have visual feedback on the screen. So that's a kind of a truly multimodal interaction. Another example that I want to show you, and it's out of different areas, which will come together afterwards in the adaptive framework, is about types of interactions that people have. So here we will see a person with what she perceives being a very efficient interaction. Just a second. How am I going to enable that?
Phone, contacts.
Which contact would you like to call?
Home,
Calling home at home.
Yeah, she's driving. It's all on the road studies. Yeah. And yeah, but I wanted to show this in particular an opposite to a more interactive user.
Give me WFM. Give me what's it called? FCR.
Pardon?
FCR.
Please confirm 88.5 FM WFCR.
Good. Good job.
Tuning radio to 88.5 FM WFCR.
Lee Martin, Miller, General Manager of WFCR. Thank you.
So these two in particular show a spectrum of how people would like to interact with the system, with having researched that about 1/4 of all the dialogues are rather interactive. Pleasant interaction is the focus. Goal is always task completion, of course, where 75% of the dialogues are have to be efficient in the car environment. Siri type of prompts for those people are really not a good fit in this situation. They want short prompts, short dialogue time, efficient dialogue strategies, and they just want to do the task. But there is this 1/4 of dialogues where it's different, and we just keep that in mind. And then an interview, we try to apply a lot of interview strategies to get a lot of information of people, of how they would want it.
How much responsibility do you feel for
learning the system versus how much the system should accommodate you?
I'd say 40-60. 40 on my end, 60 on the systems. Will the system have the capability to learn for an individual?
That's certainly the ultimate goal.
Right.
I mean, that would be ideal if it could sort of discover what you like and do it that way.
Start out with a framework and then figure out my idiosyncrasies.
Yeah.
Very mellow. So this person actually says, okay, 40% my responsibility, 60% the system, but if you really observe data, you see that users have, they're incredibly willing to adapt to a system, and they try to do it very quickly. If a system behaves twice in a certain way, the user's already adapting to it, and then if he got it wrong and he shaped a wrong mental module about the system capabilities, the user's like constantly adapting. But what's most important is that all our studies show that people highly appreciate the system adapting to them as well. Also efficient users who just want to get the task done. It's not only for interactive users saying, oh great, the system knows me, it knows my personality and what I want. It's really also for efficient task completion appreciated. So this is just a few areas where we can see in our user studies or observe certain things. Let's go to some of the most important key findings of all of those user studies. And the first two I write down here, and they're not really in the focus of an adaptive framework or anything, but they're just the basics. Everybody says, I want to know what's going on and be grounded. Things can go wrong, that's not a problem. But people need to know that's what went wrong and how is where the system and I get it right now. They need to know at every point in the dialogue what the system understood so far and what's the next requested step. They don't want to get lost or not knowing what the system requests in a certain prompt from them. And the other one is, I need to know when it's my turn to speak. And that's really very basic, basic principles that we are ever applying since we have learned to talk, to communicate with our environment in a certain language. And each language has its own cultural norms on how to achieve grounding and turn-taking. And whenever we design a speech system, it's the both most important things. But as I said, it's not really what I'm targeting at. The other things that we found in all of those user studies as common ground is that people would like a system to guide them in the beginning and be brief later, in particular in the situational context of driving. They want the system to talk to them in their preferred interaction style. And this is why I brought those examples, because we observed that in Germany and China and in the US and on-the-road studies in all of those three countries. And the difference is just how this applied within the language itself, culturally. But there is still always this, and it's a 75% relation in a car environment of dialogues which are preferred to be either in this style or in the other. And that's very interesting. And then the last one, it would be best if the system can learn me and adapt to me. So if we look at all of this, there is a lot of possibilities for adaptation. Guide me in the beginning, be brief later. Talk to me in my preferred interaction style, learn me. And then do it according to the law of reciprocity of social behavior, do it the way I want it. And I told you I want it. So, so that's why I started with user studies. Bring some areas here to your attention where there's potential for adaptation, where we have seen the potential for adaptation, and where we are trying to apply it. Now, how does this translate into technology? And here I'm going to talk now a little bit about the total other side, the technology side, to show you how we could integrate an adaptive framework into speech systems, into automotive speech systems. Now, some of those slides are highly overloaded. I did this just to give an overview. I will point you to those points in the slides that are important for me today. but it will give you the option to look afterwards through it again with more information on the slides to understand better or more in depth what I was talking about. Well, that's an in-vehicle speech system. The typical modules of a speech system I will not go through, but notice that everything goes through the user interface, which is not only a speech interface, but it has the other modalities available. The center stack display in our case, the cluster display. We could think about head-up displays for the future. It's not currently on the roads by GM cars, but it's a wide research area. Head-up displays to project information, visual information back to the user. And then we have the steering wheel controls. We could also have controls in the center stack. Germans, for instance, love rotary push buttons, also as part of the speech interaction. So the interface is much broader than just the typical speech modules. Now, looking just at the speech system, until recently, those speech systems in cars were local. They were embedded speech systems with their typical limitations and advantages. But now we are going hybrid. That means General Motors has taken the approach to go to a cloud server just for the modules of the speech recognizer and semantic parser. Sometimes, in certain cases, doing a parallel recognition approach, which has the need for a result arbitrator, which of the results coming back should we trust. But it opens up, of course, the possibilities that Siri and Google and Cortana and all those personal assistants are using for a few years already of cloud, location-based services, cloud dynamic content, and everything else that sits in the cloud. Okay, so let me just say in one sentence that there are some advantages for both of the sites. And I'm not going to go into it. But what's very important is that on generic cloud speech recognizers, which are used for many domains and users, adaptation is currently not yet an option. Adaptation to a specific user in a specific car for a specific use case. This may change, but it's expensive today, and we do not implement it. Whereas a local speech recognizer in vehicles has the disadvantage of more limited use cases, but it can be really highly dedicated to a specific user or to a very small group of users driving a car, depending on additional technologies such as user identification being available or not. So now, thinking about how we should add an adaptive framework then to this kind of speech technology in the car environment, and having again here the hybrid approach that we are going to take, we decided to implement the adaptation module locally. It has the advantage. We also decided not to make it part of the speech system, but just part of the HMI system with an API to basically all HMI components, capturing also interactions that are done by other modalities, being able to capture canvas data coming from all kinds of vehicle components, right, that can provide us with additional contextual information about the driving situation. We also have the opportunity to get such contextual data through the cloud back into the HMI because we have a connection also there. So this is why we have taken the approach to implement an adaptation framework locally. There is the limitation of memory and processing time and all this. There are delays that we have to overcome. But currently, it's the best option. Now, that's a highly overloaded slide. It just shows you a potential adaptive system with the internal modules that we are going with. The basic idea is that it's talking, as I said, to a speech system and to the HMI available data. And so if we look at the left, we would capture interactions in a knowledge base for a task. We would then, for each adaptive feature, and you will see a few soon, and then I can go more into detail, we built a user model. So for instance, if we track the history of tasks to know what task does the user more frequently request than others, then the user model will hold the patterns for that particular feature. If we build, let's say, and it will come up a feature of interaction style, then the user model for that particular user will hold the pattern of which type of interactivity the user may prefer based on the user history. So the user model basically for each adaptive feature builds a pattern of available data already that can fit in directly to the adaptation process. Then, of course, we have an adaptation module that does the actual adaptation for each of the dialogues or each of the stages where we need it. And all the rest here. An adaptation controller is simply there to control if adaptation works. As it sits locally in the car and we cannot really control it on a server, we can never really look into it again. We sell it with the car and it's done. We have a controlling mechanism that would basically go per adaptive feature and think about the important things to control, like task completion rate drops. We can tune the adaptive module automatically, these kind of things. And of course, we provide real-time context, all of that. But the general idea is, on one hand, we capture the history and all the data, we translate it into patterns, and on the other hand, we send the data for adaptation within a speech dialogue or whatever, and then we do the adaptation based on the user pattern we have seen. Yeah. Now, let me show you a few examples of typical adaptive features that are going to be implemented soon or are implemented right now. What user needs can be addressed based on what we have seen in the user studies before. Yeah, the first one I've talked about, we can track, small, the font would be bigger. So we can basically work on performance improvement. Speech recognition performance is imperfect, and any kind of improvement is still very welcome, I would say. So the user task history that let us know, for instance, which tasks were frequently done over other tasks. For instance, which are the most frequent contacts that a person calls in his phone book. Which are the typical music artists that the user hears currently, or in the near user history? What are the preferred apps? What are destinations that you request repeatedly routing for? And we may know this from Waze. When I go home, after work, Waze pops up home, and I just have to say yes. So these kind of things. But we use it, first of all, for performance improvement. So we track this history, and we get an NBAS list. Before it goes to the dialogue manager to decide how we go on in the dialogue, we take the confidence scores of the NBAS list results. After acoustic and semantic processing, we add the additional score of the a priori probability of the user history there. The algorithm is very simple. It's a simple multiplication because we assume that the probabilities are independent one from each other. And then we have some redistribution algorithm because the multiplication makes the score redistributed differently. And we add some contextual weight, and we add some normalization if an NBAS list is mixed and have different levels or different tasks. But altogether, it's very simply done. And I could just show here from the typical data some improvement that if we look on the original scores, we can see that from the left to the right, basically, if the good ones are blue and the bad ones are red, we get to a much better distribution of the scores. So it's not only about better task completion, but it's about saving confirmation cycles, because if we can the correctly completed task or the correctly recognized items basically give it a higher confidence score and we save a confirmation cycle, that's also very valuable for efficient interaction. Another thing that we do for performance improvement is language model update based on the typical natural language patterns that the user uses. In particular, efficient users always repeat the same patterns over and over. They say, call John Smith on mobile, call Jim at home, call. They would never come and say, I would like to, suddenly, or rarely, let's say. So we conducted that research with Carnegie Mellon, and we did not do it on our production system. but it's basically, and we combined it with, in this hybrid approach with the Google API, the Google ASR actually. And what we can see, so the Google ASR performs constantly, and then we see that there's an adaptive curve there when we adapt the language models over time. We can basically see, we also have, I should say, in our embedded system, combined finite state grammars with statistical language models. The idea is that finite state grammars, if they capture the most frequent utterances, produce higher confidence score. We can easily implement a new task for which we don't have the capabilities to train. And so we have a combination here where we can see that adaptation over time basically improves performance. So now we come more to the usability features. That's actually a very nice little one that we have implemented for using the past history. So assuming a user has more than one John in his phone book, and assuming he always says call John, and he doesn't want to say call John Smith, and it's always only John Smith on his mobile phone he calls, so we can capture this, and instead of bringing always the same dialogue of disambiguation over and over again, we can dynamically update the prompt and directly say which one, John Smith on mobile, and transfer this ambiguation to a confirmation task. It's really a pure usability thing because the user has no need to look at the screen while driving, and we also save a dialog step. Here's the interaction style that we have seen in the beginning. Interaction style is something that depends on the dialogue and not really on the user, because the user may be predominantly efficient, but sometimes, for some reason, he's in a more interactive mood. And so we adapt for dialogue. We actually play efficient prompts, because that's the majority of the interaction, until we detect the first interactive utterance from the user, and then we switch to more interactive prompts. More interactive prompts, that's kind of a linguistic feature. We have done extensive research on it. It's a lot of non-task talk. It's getting to a different formality level. It's more informal. And basically also more expressive, showing more surprise or a feeling of success in the prompt. And so here we need a more expressive PTS. Yeah, not sure I got it. Call John Smith. Is that right? Oh, all right. And sorry, we kind of. And it's important to not overdo it. We really have to do it widely. Another one I said in the beginning, guide me in the beginning, debrief later. We adapt to the expertise level in that framework per domain. So if there are some tasks in a domain, like phone calls, we have done a few times. We assume the user now knows. We go to more efficient prompts. Here's just an example from the navigation domain. If the user asks us for a place of interest and we have to play back a list of Starbucks or Larry's Coney Island or whatever, the user basically has to go to the search list search, and speech systems cannot really keep the listening window open in the noisy car environment for such a long time. So we tell the user at the beginning, because it may take you a while to choose, leave the manually from the display and close the speech session. So hearing this over and over is not necessary. After some time, you just get more brief. And if the user hasn't used the system for a very long time, we go back to more elaborate prompts. Now, one last to show you. Very often, the dialog pace of the speech system may not be the dialog pace in particular of very thoughtful users. And so, or of the very fast users, overlapping at the transition relevant place in a turn the last syllable of the system. And so we could think basically of doing second speech detection, and if we detect speech, we can do multiple things. We can either send it to a second pass recognition, cutting out the pause and adding those frames. We could also track it over time and adapt the parameters. And what also we can do, we can track system response times with delays. For instance, if you're looking for a place of interest, a speech system, in particular, if you go out to a server, may take 3, 4, 5 seconds, and the user not getting feedback from the system gets nervous. So we could just say, okay, in particular, that task always takes more than X seconds. Replay, please wait. So these kind of things. We have others. So what I actually, and that's my conclusion here, wanted to show you today, that based on user needs, we have an adaptive framework implemented. Within that, I've shown you a variety of those features that users would want. Now, when we do such adaptations, we need to make sure that's basically what I want to take home in the conclusion. We need to make sure to evaluate that those features do not interfere one with each other. So each feature is targeted to improve something. So we need to make sure that if it's multiple features for performance improvement, that they actually work together and do not really make it worse. So yeah. So and also, if there is this multitude of adaptive features and the user feels it, does it really, the way we implemented it, gives the user a holistic experience, a personalized experience? Is this really, when we implemented all, what the user wants? Or did we do something that we said, well, that's a little awkward, that I don't want? So then it goes back to the user studies that I have started with. Yeah, so with this, thank you for today.